Let's solve the following linear inequality. So here we have absolute value of x minus 1 divided by absolute value of x minus 2. So this is greater than or equals to 0. Here it's also given that x cannot take the value plus or minus 2 and x is a set of real numbers. So let's begin. So to solve this particular linear inequality, we'll make an assumption that let's say the absolute value of x is given by y. Now that means our inequality will become y minus 1 divided by y minus 2. So this is greater than or equals to 0. Now to solve this particular linear inequality, we need some critical points or critical values. So the critical points are defined as the points where the numerator goes to 0 and the denominator goes to 0 as well. So this gives us y equals to 1 and y equals to 2. What we'll do on the number line, let's do it here. On a number line, we'll take 2 points, which will be, so this is a number line that represents the values of y. So we'll have 1 and 2. We have now divided the real number line into 3 parts or 3 parts. So this is the region to the left of 1. Let's take a value. Let's say y is equals to 0. So y equals to 0 means it's a value which is lying to the left of 1 and it's less than 1. So in that case, what we'll do, we will substitute this value into our rational expression y minus 1 divided by y minus 2. So this will become negative 1 over negative 2, which is simply a positive value. So that means when we take values of y less than 1, we get positive values. Now we'll take a value lying between 1 and 2. So let's say we take y to be equals to 1.5. Then we'll have y minus 1 divided by y minus 2. So this will become 1.5 minus 1 divided by 1.5 minus 2, which gives us 0.5 divided by negative 0.5, and we'll get a negative number. So that means if we take any value of y between 1 and 2, we're going to get a negative value. And let's say we take y to be a value which is greater than 2. So let me take 4. Then in that case, then our expression y minus 1 divided by y minus 2 will be 4 minus 1 divided by 4 minus 2, which is going to be a positive value. So that means we are going to get a positive number. That means we have to consider a region for this particular inequality such that we have a positive value greater than 0. So we have this three region. Of this three region, 1 and 3 are the region where the value of y minus 1 over y minus 2 is greater than or equals to 0. So now we will consider the solution set, so which is y will be taking the value less than 1, or y can take the value greater than 2. Now y can take the value less than 1, or it can also take a value equals to 1 because that's allowed. However, we cannot take y to be equals to 2 because if we take y equals to 2, then this will become a division by 0, which is not allowed. Now that we have the value of y, we can substitute back the original value of y, which is absolute value of x. So we have absolute value of x less than or equals to 1, or we can say absolute value of x is greater than 2. Now using this, we have to find out the solution for x. So let's do that. So by definition, when we have absolute value of x less than or equals to 1, we can say that x must lie between negative x and positive x. Or when we say x is greater than 2, then it could have two possibilities. Either x could be greater than 2, or we can say x could be less than negative 2. So what we'll do, we'll try to combine all the three solutions. So here we'll consider a number line. On the number line, we'll have negative 2, negative 1, 0, 1, 2. So here, x lying between negative 1 and positive 1, that would mean we'll consider the region for lying between negative 1 and positive 1. We have x greater than 2. So x greater than 2 means all the values of x which is greater than 2. And x less than negative 2 will be all the values of x which is less than 2. So the common solution will be from negative infinity to negative 2. Negative 2 cannot be a part of the solution, so we'll use an open interval here. Union will go from negative 1 to positive 1. Here negative 1 and positive 1 are both part of the solution, so we'll use a closed interval. Union, and we have values greater than 2, that means it will go from 2 to infinity. So this is the value of x. So this is a solution to the given linear inequality.